In 1868, in a monastery at Brunn, Austria, an Augustinian friar, Father Gregor Mendel, is working on his experiments with peas. And in 1868, he publishes in the Brunn Academy of Science journal a treatise on pea hybridization, in which he formulates what he calls laws of heredity, as they apply, in his estimation, to pea plants. This is Mendel's publication of the laws of genetics, 1868. In 1869 is reported the discovery by a chemist, Friedrich Miescher, in Switzerland, that is also revolutionary, but no one knows it. Friedrich Miescher is working in Switzerland in a Red Cross facility on patients from the Crimean War. At that time, much before the development of disposable bandages, and Miescher is working in a unit where the bandages used on the war victims are actually washed and reused, and sterilized and reused. And Miescher is taking the material that's washed off these bandages, basically pus from the wounds, and in there would be white blood cells. And Miescher discovers in this a material that he calls nuclein. Nuclein is what we come to call today DNA, deoxyribonucleic acid. So within a matter of 10 years are reported the theory of evolution in Darwin's Origin of Species, the laws of inheritance and genetics in Mendel's paper, and the molecule DNA. None of these three knew the importance of their discoveries one to the other. It's clear that Mendel knew about Darwin's book. It had been published some 10 years prior to his publication, and of course in the succeeding time of his career, and I'll talk more a little bit about Gregor Mendel later. He was at that monastery and was at seminars and meetings and in classes where Darwin's theory of evolution was being discussed. But it's probably clear that Darwin knew nothing of Mendel's discovery. Many prominent scientists of Mendel's day, in fact, had his paper in their collections, and some were even found unopened, never even read. No one of the two of them, we're sure, pretty much sure, knew anything of Miescher's discovery of DNA. No one knew what DNA would do at that point or what its importance would be. But by the middle of the 20th century, those three developments, Darwin's theory of evolution, the laws of Mendel and genetics, and the molecule DNA, would come together to make what we call modern biology. So this decade of the 60s in the 19th century, from 1859 to 1869, is a very critical time. Now, Darwin's publication of On the Origin of Species raises an issue for the first time with biology and our faith, you might say, because it raises for the first time a new view of the living world. Prior to Darwin's view, the view of scientists had been that everything we see in the living world is as God created it originally. But Darwin argues that species, as we see them, the species that Linnaeus had defined in his binomial definition, that these species actually evolved from pre-existing species, and that everything in the living world was a kind of linearity of descendants from priorly existing species. What we know as the theory of evolution is still that essentially today. Now, the challenge to faith, the challenge, let's say, to the church's teaching at the time, was thought to be quite severe and was fought in many quarters. If we actually look back in church history, though, and we look at the writings of St. Augustine, for instance, we find that Augustine would not have been bothered by evolutionary theory. Augustine wrote in his, I think it's in City of God, that his view was that creation happened in two forms, that creation happened in the form that God created it, and also in what he called an incipient form, which would develop later into what God wanted. So Augustine and probably Aquinas would not have been, we think, from their writings, bothered by Darwin's theory. But in the middle of the 19th century, especially in some of the churches in England, this was a turmoil-creating kind of proposal, that evolution had occurred. As a result, Darwinians, or Darwinists as they were called, were seen to be opposed to church thinking, perhaps creating the first, a further division, as we've been seeing this division grow, between science and church thinking. Now, biologists embraced Darwin because it explained a lot about what you saw in the natural world, how various forms seem to be related, some more distantly than others, how you could argue that one thing came from the other by some kind of progressive evolutionary development. But the theory was a problem for the physicist. Darwin proposed in evolutionary theory that evolution proceeded by a force, and that the force of evolution was the force called natural selection. Now, natural selection, Darwin proposed, acted as a force in nature to drive evolution. Now remember, we have physics, which is the queen of the sciences, with its own theory and its own language, and a series of laws that Newton had formulated, which described the effect of forces on the physical world. We have scientists who, according to Hume's definition of science, should only be concerned with the physical or material world. So here we have a biologist proposing a force, natural selection, which should act on something. And so the physicist's natural question would be, on what does the force act? What does natural selection act on in the physical world? What physical entity does it have an effect on? And of course, Darwin had no answer. No biologist in the 19th century had an answer for that question. So what began to look like a sound theoretical foundation for biology, that is, this idea of evolution and species relatedness, a way of making predictions maybe, was, when it's jammed up against physics, seen to be lacking, because we had nothing on which this force of natural selection would act. Biologists then are cast into the unenviable role of being compared to physics. Still an immature science, still descriptive, now with a theoretical basis which may or may not have any reality because it had a force upon which nothing could be the thing it acts on, no object in the natural world. So biology enters the 20th century, the beginning of the 20th century, looking to catch up with physics. Now, several things happen in the 20th century, and we're going to spend a good bit of the rest of the lectures talking about this. One thing is, Mendel is rediscovered at the beginning of the 20th century. Mendel comes back into prominence. Mendel is lost for 40 years. His publication in 1868 is all but ignored. By the beginning of the 20th century, however, things in biology have changed, such that Mendel's ideas and laws begin to correlate with things that are observed in the biological world, especially with respect to what we'll call the behavior of cells. And I'll come back to that a little bit later in our discussion. In addition, in the 20th century, we have the rise of what I'll call biochemistry, the chemistry of biological systems, something that wasn't really happening before the beginning of the 20th century. It was really at the end of the 19th century that organic chemistry and the idea of molecules from living systems began to be a prominent part of chemistry. And it wasn't really until the beginning of the 20th century that the science we now call biochemistry, that is the chemistry of living systems, began to take a prominent role. Thirdly, we have the development of the discipline of molecular biology. Molecular biology really comes into its own after World War II. It's actually born as a result of World War II in a history I'll tell you about a bit later. And as a result, we have a discipline which is, as we speak right now, not much more than 40 years old, but has become the central discipline of modern biology. Molecular biology itself was a child of physics. Aha, physics rears its head again. So now we see that biology is beginning to take on a characteristic in its change by the middle of this century, which is trying to make it look more and more like physics, the science it's been trying to emulate all along. So we have now genetics, we have biochemistry, and molecular biology coming together.